Hello everyone, Mr. John here from Areteem Institute with this week's Thursday Tidbit, where we're going to be revisiting Vieta's formulas and be talking about them for cubic equations this time. Little bit of review, we did this already in a previous video for quadratic, so check out that video if you want a review of this. But just to start seeing the pattern, if we have a quadratic equation with two roots r and s, and then we can use Vieta's formulas for telling us the sum of the roots. So our first equation here is the sum of the roots, r plus s is negative b over a. And we also have the product of the two roots, so the two roots multiplied together is c over a. So just knowing the coefficients of that quadratic gives us information about the roots. So you might expect, and it's true, that a similar formula or a similar type of formula is true for a cubic equation, a cubic polynomial. So now cubic, three roots, r, s, and t, and we have ax cubed plus bx squared plus cx plus d. Then Vieta's formula tells us the following. So first of all, we start out again with the sum of the roots. The first root plus the second root plus the third root is still negative b over a. Now we have a little bit of a difference with our second equation. When we had a quadratic, there were two roots. So now our second term is two roots multiplied together, all the possibilities. So r times s, r times t, s times t, and those three values are added up, and that's what gives us our c over a. So we have the sum of the roots is negative b over a, the sum of the product of two of the roots is c over a. Now, what is our third term? Well, we have single roots, double sets of roots, and then now all three of the roots put together. So our third formula is the product of the roots, r times s times t, is negative d over a. So this is kind of an extension of that quadratic. We'll see in future videos that this works for higher degree polynomials as well. But let's explore this cubic one and actually look at an alternative way of going through the proof of this. So looking at our setup here, right? So let's say we have our three roots. Notice here I'm missing an a. You can of course just divide by a if you want to get rid of that coefficient of the x cubed, right? So we can divide by a first. And then that gives us x cubed plus bx squared plus cx plus d. Doesn't change anything. It just allows us to kind of do a simplified proof of this here. Now, if we're given the three roots, that is a clue about how this would need to factor, right? If r, s, and t are the roots of the equation, that means it's definitely going to need to factor with r, s, and t. This is the reason that we wanted to get rid of that a term. So we have just x minus r, x minus x, x minus t. Now, this of course cannot actually change our equation, right? This has to still be equal to our cubic polynomial, x cubed plus bx squared plus cx plus d, right? Factoring it doesn't change anything. So if we start looking at this, right, of course, multiplying this out, x times x times x, that's going to give us our x cubed, right? So that's how that first term will come up in that case. Well, what if we start looking at other terms from that? How can we get things like an x squared? Well, if we have two x's and then minus t for the third term, right? So we have x times minus t. That's going to give us some expression with an x squared, right? So this is going to give us a minus t in that case, right? Well, what if we have the first and third x's, and then we have a minus s for our middle term? Well, that's going to give us a minus s, of course. Still x squared, right? So minus sx squared, but if we're just looking at the coefficient, that is just going to be a minus s. Well, we also have then a minus r here as well. So minus r, and this is our coefficient of x squared. So this is supposed to be b. Right? Now, notice this is almost exactly our expression. We're supposed to have negative b over a, right? A is 1 in this case. So if we make all of these things positive, right, plus r plus s plus t, this is going to be giving us a negative b in that case. So, right, negative b over a basically is the sum of the roots there. And this is the game we can play for all of the terms, right? We can do some of these a little bit quicker in this case. Well, what if we just want a linear x, right? Well, we could have negative r negative s times x. So that gives us a positive rs in that case, right? Then, right, what if this middle term is the x, right? So then we have negative r negative t times x, so that is plus r times t. And finally, right, we look at negative s, and the first term is our power of x. X times negative s times negative t is plus st. No negatives to worry about here. This is supposed to be our c value. Our linear term has a coefficient of c. So we have c over a because we divided by that a first. Now when a is 1, it is just c. Very similarly here, what is our constant term? The only way to get the constant is negative r, negative s, negative t. So we have negative rst is equal to d. And then moving that negative over, we of course just have our RST is negative d as we needed in that case, right? So that gives us our value that we want there. Sum of the roots is negative b or negative b over a. If you have the a, the sum of the product of two of the roots together is c or c over a. And then the product of r, s, and t, all three of the roots put together is negative d or negative d over a in the general case. And that idea of the proof can be extended further as well to higher powers and higher degrees of polynomials, which we'll explore in a later video. In this video, I want to make a special announcement. So this Vieta's theorem formula here is a great formula that you will see in a lot of math contests, and it's going to be typically an algebra topic in those contests, right? Polynomials, roots, equations, all of that stuff as well. So we're taking the next couple of weeks to highlight some great math contest supplemental math ideas. And if you want to learn more about these things, our online math camp in July is a great way to learn more, have fun, right? These are 5-day camps each week for a lot of learning, a lot of improvement this summer. These camps are open to middle school up to high school students. Each week we'll have a dedicated topic in terms of algebra, geometry, counting and probability, and number theory. As I mentioned, this Vieta's theorem is a great, very important topic in algebra. So click the link in the description below for more information, and I hope to see you guys this summer at this online summer camp as well. It's a lot of fun, a lot of work, and you'll learn a lot along the way as well. As usual, check back each week for one of these Thursday tidbits every week in 2021. If you like this video, please subscribe below, right? Check out our previous Thursday math tidbits, and I'll see you guys again next week. Goodbye.